Space may seem empty and dark, but it's actually a giant cloud of gas and dust. We call these clouds nebulas. These nebulas are like nurseries for stars. Imagine a cloud of flour. It's fluffy and spread out. Now imagine you squeeze a part of that cloud. What happens? It clumps together, right? That's kind of how stars are born. Gravity pulls the gas and dust in a nebula together. The clump gets denser and denser. It heats up as the particles collide. This continues for millions of years. Eventually, the core gets so hot and dense that something amazing happens. Nuclear fusion begins. This is the process where hydrogen atoms fuse together to form helium. This releases enormous energy. This energy makes the star shine brightly. A star is born. The universe welcomes a new light. The size of a star depends on how much gas and dust it collects during its formation. The bigger the initial cloud, the bigger the star. Think of it like baking cookies. More dough means a bigger cookie. Our sun is a pretty average-sized star, but some stars are much, much bigger. Not all clouds of gas and dust become shining stars. Some just aren't massive enough. They never get hot enough in their core to start full-blown nuclear fusion. These are the brown dwarfs, the failed stars of the universe. Brown dwarfs are like the toddlers of the star family. They are bigger than planets, but smaller than stars. They might glow a little bit from the heat of their formation. But they are not as bright or as hot as real stars. Even though they didn't quite make it to star status, brown dwarfs are still fascinating. They can teach us about the conditions needed for star formation. And who knows, they might have planets of their own. The universe is full of surprises. Most stars in the universe are main sequence stars. This is the stage where stars spend most of their lives. Our sun is a main sequence star. It's been fusing hydrogen into helium for about 5 billion years. Main sequence stars come in different sizes and temperatures. The smallest and coolest are the red dwarfs, like Proxima Centauri, our closest stellar neighbor. They are much dimmer and cooler than our sun, but they live for trillions of years. Then there are stars like our sun, classified as G-type stars. They are yellow-white and have a lifespan of about 10 billion years. Bigger and hotter than our sun are stars like Sirius, the brightest star in our night sky. Sirius is a white star, twice as massive as our sun and much hotter. It burns through its fuel faster, so it won't live as long. Section 4, Red Giants, Expanding Horizons. After billions of years, a main sequence star like our sun starts to run out of hydrogen fuel in its core. The core contracts and heats up. This causes the outer layers of the star to expand outwards. The star becomes a red giant. Red giants are huge. If our sun became a red giant, it would swallow up Mercury, Venus, and even Earth. Its surface would cool down, giving it a reddish appearance. This phase doesn't last forever. Eventually, the red giant will run out of fuel completely. Its outer layers will drift off into space, forming a beautiful planetary nebula. Section 5, Hypergiants, Cosmic Titans, and the Fate of Stars. Now let's talk about the real giants of the universe, hypergiants. These are the largest stars we know of, and they are truly colossal. Imagine a star so big that if you replaced our sun with it, it would extend out past the orbit of Jupiter. One famous example is UY Scuti. It's so large that it would take light more than 8 hours to travel around its circumference. That's like flying around the Earth 8 times at the speed of light. Hypergiants are rare, but they are incredibly bright and powerful. But this incredible size comes at a cost. Hypergiants are unstable. They are constantly losing mass through powerful stellar winds. They live for only a few million years, which is a blink of an eye in cosmic terms. Their end is also dramatic. When a hypergiant runs out of fuel, it collapses in on itself. This triggers a supernova, a massive explosion that can outshine an entire galaxy. The material ejected from a supernova can eventually form new stars and planets. So in a way, the death of a star can lead to the birth of new ones. The cycle continues. And if you want to explore the universe and learn more about stars, check out the Universe in a Nutshell app. It's a great way to discover the wonders of space.